So the next few questions involve factoring binomials 11, 12, and 13. And so when you see a binomial on our review, you want to first determine what type of binomial is it and which formula will I apply to factor. So starting with number 11, once we identify that this is the difference of two perfect squares, and the identifier is the fact that you have an x squared, right? And once you determine the square roots, or we prove that both terms are perfect squares, for example, x squared, I know that x times x equals to x squared. With the 4, obviously 2 times 2 equals to 4, so we do have the difference of two perfect squares. Once you identify that, it's just a matter of using the formula to factor. So your a is your x and your b is your 2. So creating the factors is very easy because a squared minus b squared is equal to a minus b times a plus b. So we simply write the factors as x plus 2 times x minus 2, and we're done. Now with the next question, we are clearly looking at something that's not the difference of two squares because we have a 3. So now it's just a matter of identifying which formula for our cubes is the correct formula to use. Is it the sum of two cubes or the difference of two cubes? Well, we have the difference here, and the only thing we need to do is we need to prove that this is the difference of two perfect cubes. So clearly the x to the third is a perfect cube, x times x times x. And when it comes to the 512, you just want to take the cube root of that number. You can use your, of course, calculators, and hopefully everyone knows how to set that up using their calculators to find the cube root of 512. And you would find that 8 times 8 times 8 is 512. So we have the difference of two cubes. So the answer is written using a as x and b as 8. So we plug in the values into the correct formula. So this is the correct one, a cubed minus b cubed. So we have a minus b, so that's x minus 8 times a squared. When I square x, that'll be x times x, so that's x squared, plus multiply a times b, that'll be x times 8, which is 8x, plus square b. And since b is 8, when I square it, 8 times 8 is 64. And that's my answer. Now we move to the next one, number 13, and we have another binomial that appears to be a perfect cube because we have the x cubed here. So we just have to prove it. We have to write out how they're perfect cubes to confirm it. So of course 4x times 4x times 4x proves that 64x to the third is a perfect cube. And using your calculator, you can find that the cube root of 27 is 3 times 3 times 3. So our a is 4x and our b is 3. So now we're using the a cubed plus b cubed formula. And we have our a and b. So we simply write out the factors. So we have a plus b, which is 4x plus 3. Then a squared, so I'm going to take the 4x and square it. 4x times 4x, right? 4x times 4x gives us a squared. So that's 16x squared. Minus a times b, 4x times 3 is 12x, plus b squared, since b is 3 and we square it, 3 times 3 is 9. And you're done. So 11, 12, and 13 are solved, are factored using the correct formula for that particular binomial, and you'll have your formula sheets for that. Now we're going to move to solving equations, but in order to be able to solve equations correctly, we have to know how to factor correctly. So taking the first equation for number 14, when I look at this polynomial on this side of the equation, right? In order for us to be able to solve the equation, we do need to make sure that it's in standard form where all of your polynomial terms are on one side and 0 is on the opposite side here. And we have that initially with this equation. Now I have to determine, well, how am I going to factor this polynomial? Well, it's a binomial. It appears to be a perfect square, but is it? Right? I see the x squared, but 8 is not a perfect square. 5x is not a perfect square. So then that brings us to, well, it's not a perfect square. It's not the difference or sum of cubes. So the only other thing I can think of when it comes to a binomial is to factor the GCF. And 8x squared minus 5x does have a GCF, and the GCF is x. So when we factor out the x from the polynomial, that leaves an 8x minus 5. So now we're using the zero product property in order to solve, which means I take each factor, and I have x as a factor, take that factor, set it equal to 0, in other words, create an equation out of it. I take the other factor, 8x minus 5, set it equal to 0, so it creates its own equation, and then I make sure both equations are solved. X equals to 0 is already solved. The answer is 0 here. Over here, I'd have to add 5x to both sides in my first step, and then divide by 8, where x equals to 5 over 8. So my solution set, which in my lab, it just wants you to write your answer separated by a comma. My solution set is 0, 5/8, right? That's the answer. X equals to 0 or x equals to 5/8. But in my lab, you only write the 0 and a comma and the 5/8. You don't need to actually include the braces. All right, let's look at the next equation. We have 4d squared plus 7d plus minus 2 equals to 0. So we need to, it's in standard form, right? Everything. All right, so we multiply our a times c, which is a -8. We have -1, 8, -2, 4. Of course, -1, 8 is what we're going to use. And we start to factor by, of course, keeping the first term and the last term, but replacing this positive 7d with a minus 1d and a positive 8d. So now I factor by grouping, and my GCF for the first group is 1d, and that factors out to 4d minus 1. My GCF for the second group is a positive 2, and that factors out 4d minus 1 as well. So my factors are 4d minus 1 times d plus 2. Now that I have factored this trinomial, I have my factors here. Now it's time to use the zero product property. So I take both of these factors. There's my first equation, 4d minus 1. The second equation is d plus 2 equals to 0. And solve. So I'll add 1 to both sides and divide by 4. And my first solution is 1/4. The second solution is simply found by subtracting 2, and d is a -2. So my solution set is simply 1/4, comma, -2. That's all I would write. I would type into my lab. I'm using the braces here, of course, to identify the solution set, the answer. But in my lab, you will only type in the 1/4, comma, -2 for your result. Now, we're moving to number 16, where the equation is not in standard form, all right? It's not in standard form, meaning We do not have x squared plus bx plus c equals 0. We don't have all the terms on one side and one side equal to 0. So we're going to make it that way. I cannot do that by just taking the 6x and the 16 and moving them over, but I can subtract 16, subtract the 6x and the 16 from both sides, which would create x squared minus 6x minus 16 on the left, and the terms zero out on the right. So now it's in standard form. Now we can factor our trinomial, and this is a trinomial where the leading coefficient is 1. So we don't even need the AC method here. All we need to do is list the factorizations of our c, which is a negative 16. So we have 1 times negative 16, 2 times negative 8, and 4 times negative 4. So we're going to use the positive 2 and the negative 8. Since this is not the AC method and it's just a regular trinomial, that's all we need to do is we just need to write our x's, and one has x plus 2 and the other has our x minus 8. Now that everything's factored in our equation, we can start to use the zero product property, which means taking each factor, the x plus 2, creating an equation equal to 0, and the x minus 8. The answer for the first equation is negative 2, and the second equation is a positive 8. So negative 2, 8 is our solution set. So we would simply write our answer as negative 2, 8 in MyLab.